Welcome to Sri Ramchan Physics Pilot. இந்த வீடியோஸ் நம்ம பார்க்கக்கூடியது 10th standard science first lesson physicsல laws of motion. அதில் answer briefly and answer in detail. அதுக்கான answers எல்லாமே பார்க்க போறோம். அந்த questionஸ்க்கான answers எல்லாமே ரெஃபர் பண்ண போறோம். So first question, answer briefly. First question, define inertia, give its classification. So அதுக்கான answer, inertia definition: the inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced upon by an external unbalanced force is known as inertia. Classifications கேட்டிருக்காங்க. Types of inertia: inertia of rest, inertia of motion, inertia of direction. Second question, classify the types of forces based on their application. So like parallel forces, unlike parallel forces are the two answers. Third question, if a 5 Newton and a 15 Newton forces are acting opposite to one another, find the resultant force and the direction of action of the resultant force. So two forces கொடுத்திருக்காங்க. The two forces are unlike parallel forces. அதுக்கான diagram சரிங்களா, 5 Newton 15 Newton அப்படிங்கிற two forces. So you have to draw the diagram. இந்த diagram வரைஞ்சிக்கிறீங்க. 5 forces இந்த directionலையும் 15 Newton this direction act ஆகுது. So let P equal to 5 Newton and Q will be equal to 15 Newton. So resultant force அப்படிங்கும் பொழுது you have to add. சரிங்களா, ரெண்டு force நம்ம add பண்ணோம்னா resultant force அப்படிங்கிறது கிடைக்கும். Therefore R will be equal to P plus Q அப்படின்னு இருக்கும். இங்கே Q ஓட வேல்யூ வந்து -15 வரதுனால resultant R will be equal to P minus Q. அப்போ 5 plus of -15 equal to -10 Newton. So resultant R will be equal to -10 Newton. So the resultant force acting along the direction of Q. Fourth question, differentiate mass and weight. So for mass வந்து ஒரு பக்கம் எடுத்துக்கிறீங்க, weight another side. So for mass, the quantity of matter contained in a body. Weight, the gravitation force exerted on it due to the Earth's gravity alone. சரிங்களா, அடுத்தது massல it is a scalar quantity and the weight it is a vector quantity. அடுத்தது mass பொறுத்தவரையும் its unit is kilogram and weight உடைய unit Newton. And mass constant at all the places and weight variable with respect to gravity. Fifth question, define moment of a couple. So rotating effect of a couple is known as moment of a couple. So moment of couple equal to force into perpendicular distance between the line of action of forces. So M equal to F into S. இதோட யூனிட்ஸ் கூட நீங்க எழுதிக்கலாம். force it is, so இதோட யூனிட் SI யூனிட். Force it is Newton and S is to be the distance here. So distance is to be meter. So Newton meter is the SI unit for moment of a couple. Sixth question, state the principle of moments. So when a number of like or unlike parallel forces act on a rigid body and the body is in equilibrium, then the algebraic sum of the moments in the clockwise direction is equal to the algebraic sum of the moments in the anticlockwise direction. Question number 7, state Newton's second law. The force acting on a body is directly proportional to the rate of change of linear momentum of the body and the change in the momentum takes place in the direction of the force. Eighth question. Why a spanner with a long handle is preferred to tighten screws in heavy vehicles? This is because turning effect to tighten the screws depends upon the perpendicular distance of the applied force from the axis of rotation is power arm. So larger the power armless is the force required to turn the screws. So spanner is provided with a long handle. Ninth question. While catching a cricket ball, the fielder lowers his hands backwards. Why? When the fielder lowers his hands backwards, he increases the value of time of collision and so retardation is decreased. Second point. Hence, retarding force becomes lesser than before and the palm of the fielder is not hurt very much. Question number 10. How does an astronaut float in a space shuttle? An astronaut floats in a space shuttle because both are in the state of weightlessness. Both are experiencing equal acceleration towards Earth as free fall bodies. Astronauts are not floating but falling freely. Next, answer in detail. First question. What are the types of inertia? Give an example for each type. So types of inertia. First, inertia of rest. The resistance of a body to change its state of rest is called inertia of rest. Example, when you vigorously shake the branches of a tree, some of the leaves and fruits are detached and they fall down. Second one, inertia of motion. The resistance of a body to change its state of motion is called inertia of motion. Example, an athlete runs some distance before jumping because this will help him jump longer and higher. Third one, inertia of direction. The resistance of a body to change its direction of motion is called inertia of direction. Example, when you make a sharp turn while driving a car, you tend to lean sideways. Second question, state Newton's law of motions. Newton's first law. Everybody continues to be in its state of rest or the state of uniform motion along a straight line unless it is acted upon by some external force. Newton's second law. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. Newton's third law. For every action, there is an equal and opposite reaction. They always act on the two different bodies. Third question. Deduce the equation of a force using Newton's second law of motion. The force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. Let m be the mass of a moving body moving along a straight line with an initial speed u after a time interval of t. The velocity of the body changes to v due to the impact of an unbalanced external force F. Initial momentum of the body Pi equal to mu, final momentum of the body Pf equal to mv, change in momentum del P equal to Pf minus Pi equal to mv minus mu. By Newton's second law of motion, force F directly proportional to rate of change of momentum. So F proportional to change in momentum by time. F proportional to mv minus mu by t. F equal to km into v minus u by t. Here k is the proportionality constant. K equal to 1 in all systems of units. Hence F equal to m v minus u by t. Since acceleration equal to change in velocity by time, that is a equal to v minus u by t. Hence we have F equal to ma. Since you are going to change, that is v minus u by t. So this equation you are going to write as a. Therefore F equal to m into a. So force equal to mass into acceleration. No external force is required to maintain the motion of your body moving with uniform velocity. When the net force acting on your body is not equal to 0, then definitely the velocity of the body will change. Thus, change in momentum takes place in the direction of the force. The change may take place either in magnitude or in the direction or in both magnitude and direction. Question number 4. State and prove the laws of conservation of linear momentum. So there is no change in the linear momentum of a system of bodies as long as no net external force acts on them. Let us prove the law of conservation of linear momentum with the following illustration. So diagram is given. m1 mass of that object A, m2 mass of the object B, u1 is velocity of the object A and u2 is velocity of the object B. F of A, F of B, the force that acts on both the objects. So final velocity v1 and final velocity v2. Let two bodies A and B having masses m1 and m2 move with the initial velocity u1 and u2 in a straight line. Let the velocity of the first body be higher than that of the second body, that is u1 greater than u2. During an interval of time t second, they tend to have a collision. After the impact, both of them move along the same straight line with a velocity v1 and v2 respectively. Force on a body B due to A equal to F of A equal to m2 into v2 minus u2 by t. Force on body A due to B is F of B equal to m1 into v1 minus u1 by t. By Newton's third law of motion, action force equal to reaction force, that is F of B equal to minus F of A. So F of B, that is m1 into v1 minus u1 by t equal to minus of m2 v2 minus u2 by t. T and t get cancelled, so அதை multiply பண்ணிரோம். So you get m1 v1 plus m2 v2 equal to m1 u1 plus m2 u2. The above equation confirms, in the absence of an external force, the algebraic sum of the moment after collision is numerically equal to sum of the moment before collision. Hence, the law of conservation of linear momentum is proved. Fifth question. Describe rocket propulsion. So, propulsion of rockets is based on the law of conservation of linear momentum as well as Newton's third law of motion. Rockets are filled with a fuel, either liquid or solid, in the propellant tank. When the rocket is fired, this fuel is burnt and a hot gas is ejected with a high speed from the nozzle of the rocket, producing a huge momentum. To balance this momentum, an equal and opposite reaction force is produced in the combustion chamber, which makes the rocket project forward. While in motion, the mass of the rocket gradually decreases until the fuel is completely burnt out. Since there is no net external force acting on it, the linear momentum of the system is conserved. The mass of the rocket decreases with altitude, which results in the gradual increase in velocity of the rocket. At one stage, it reaches a velocity which is sufficient to just escape from the gravitational pull of the Earth. This velocity is called escape velocity. Question number 6. State the universal law of gravitation and derive its mathematical expression. This law states that every particle of a matter in this universe attracts every other particle with a force. This force is directly proportional to the product of their masses and inversely proportional to the square of the distance between the centers of these masses. The direction of the force acts along the line joining the masses. Let M1 and M2 be the masses of two bodies A and B placed or meter apart in space. Force directly proportional to the product of mass, that is M1 into M2, and F is inversely proportional to square of the distance, that is F proportional to 1 by R. On combining the above two expressions, F proportional to M1 into M2 by R square. So F equal to G into M1 M2 by R square, where G is the universal gravitational constant. Its value in SI unit is 6.674 into 10 power minus 11 Newton meter square kilogram power minus 2. Question number 7. Give the applications of the universal law of gravitation. So applications. First one. Dimensions of the heavenly bodies can be measured using the gravitational law. Mass of the earth, radius of the earth, acceleration due to gravity, etc. can be calculated with the higher accuracy. Second application. It helps in discovering new stars and planets. Third one. It helps to explain germination of roots is due to the property of geotropism, which is the property of a root responding to the gravity. Fourth one. One of the irregularities in the motion of stars is called wobble, lead to the disturbance in the motion of a planet nearby. In this condition, the mass of the star can be calculated using the law of gravitation. Fifth application. It helps to predict the path of the astronomical bodies. So these are all the question and answers, and you may write it. And it is helpful to study. Just hearing the answers. Answers it is helpful to you to memorize the answers. You may take a snapshot and write the answers. You may hear the answers also. So if you have any doubt, free to call, and we'll meet in the next video. Thank you all.